Good morning. Here we are, and we are doing Module 8, Lesson 4 today. You will need to have a straight edge of some sort. You will also need to have two colored pencils, a blue one and a green one to help you with today's lesson. And you need to make sure that you watch the video first. The Eureka video. It will be very helpful to today's lesson, and there are some things that you will need to do on that lesson. With the new teacher, there's a new teacher on the Eureka, at least for this lesson there was, and you need to make sure you're paying attention to what is going on there. So let's go ahead and take a look at what you're going to be doing today. As I said, you need to watch the Eureka video first. I get really frustrated on how that does not show up well. All right, so on number 1, you're going to use your ruler to draw two parallel lines, and you should have learned about that on the video, but they cannot be the same length. You're going to draw two parallel lines, not the same length. If you'll remember, parallel lines are lines that never cross each other. Or, if I could use the more correct term, they never intersect. Intersect means they don't cross, or they never cross. If they intersect, then they do cross. On number 2, you're going to use your ruler to draw two parallel lines that are the same length. So this one, they're different lengths. On this one, they're the same length. And I know that that space is not very big, and if you want to do it on a separate piece of paper, that would be okay with me. I know that when I did this assignment for getting ready for today, I did mine on a larger piece of paper so that I could, whoops, that's upside down, so that I could keep better track of what I was doing. So if you want to use a larger piece of paper to be able to do problem 1 and problem 2, that would be fine. And on problem 3, trace the parallel lines for each quadrilateral. I would not use a crayon. I am asking you to use your colored pencils. A crayon is really too fat. So using a colored pencil would be a much better plan. And I am asking that you use a blue and green. So blue and green colored pencils. We've been using colored pencils for a while, and we will continue to use them for a while still. So if you need colored pencils and you don't have any, please come into the school. We would be happy to supply you with those. So you are going to trace the parallel lines in each quadrilateral using a colored pencil. Please don't use a crayon. For each shape with two sets of parallel lines, you're going to use two different colors. I'm going to give you an example of what I mean by that. Let's see here. I don't want to do that one. Where did I? Oh, here it is, right here. I am going to show you the first two on problem number 3. Hang on just one little tiny second. And continuing, I just needed to get something ready. So let's go back over these instructions. I'm still trying to get through that. So if there are two sets of parallel lines, you need to use two different colors. That's why I'm asking for the blue and the green. You need to use your index card to find each square corner, and you need to put a box. You need to box it. And I am using, when I am doing those square corners or those right angles, I am using a red pencil. So just a hint on what I'm hoping that you'll do. So I am using a red pencil for those square corners, which, by the way, I'm going to be a little bit more clear about what a square corner is, because I think I'm going to be a little bit more clear about what a square corner is. And I'm going to show you the two different colors that I'm going to be using. When I'm just having one trace the parallel lines, I'm going to use blue. So blue for a single parallel line, green and blue if there's two different colors. And when you're showing your square corners, or these are square corners really are a 90-degree angle or a right angle. And it does make a square, or it makes the side of a square. They did not point this out on the video, but I'm going to add that in because I think it's important that you at least have that exposure. So a square corner is really a 90-degree angle, that would be measured on a protractor, which we're not going to be doing, but just need to know that it does make the corner of an index card. I'm going to show you that little index card here. If you're looking at the index card, you can see that each of those corners makes a square. Let's just see if I can show you that. Let's see here. I'm going to put this little paper underneath. So if I were to show you, you can see that each of those corners makes this part of a square. Coming over here, this corner is a right angle or a 90-degree angle, and it does make the side of a square. That's why it is called a square side or a 90-degree right angle. You can see that it makes a square. So, and we'll talk a little bit more about that when we actually correct the paper. So you do need to have that index card. So if it does have a square corner or a 90-degree angle or a right angle, don't really like calling them corners, I'd really rather call them angles. So if it's making the side of a square, it is called a right angle or a 90-degree angle. So anyway, there is a little hint about what you should have learned when you watched the videotape today, even though they did not use 90-degree and right. Okay, so let's give you an example of what that might possibly look like. I'm going to show you one that I did. So on polygon A, notice that it has two different sets of parallel lines that will never intersect with each other. So I'm taking my ruler and I am tracing those right angles, not those right angles, those parallel lines. The first set side by side with one color and the second set side by side with another color. Now I'm also noticing as I look at this polygon A that it does not have, and I really prefer to use a little sticky note. It's easier for me to be able to see. If I lay my sticky note right down on top of that polygon, I can see very clearly through here that it does not make that right angle. A right angle would make a square, as you can see here, but I can see right through the paper and I can see that it does not make a right angle. It's actually making an acute angle, which is just smaller than a right angle. And I really do have to test every single one of those corners. I'm testing this corner because if it is a square corner or a right angle, I do have to put a box on it. So notice that this one is larger than a right angle. I can see here's the bottom of my angle and here is the side of my angle. It is too wide. That would be an obtuse. Okay, now let's take a look at this one up here. Okay, this one is also acute. It's too small. A right angle would come clear over to here. And let's take a look at this last one. I really do prefer these little sticky notes. If you've got sticky notes at your house, this would probably be a much better way to tell whether or not, oops, I got to get that right on the vertex. Lay that down, and I can see that I have another obtuse angle here because it is larger than a right angle. So I am not boxing any of these. This is actually called a rhombus, and I think she did mention that on the videotape. All the sides are the same length, but it has no right angles. And here we have a trapezoid with one set of parallel lines, so I'm only doing one color because if I were to trace these two sides, they would definitely intersect with each other. So I'm going to demonstrate that even though you didn't need to do this. These are not parallel lines because they cross each other or they intersect each other. They are not parallel lines. That's why I'm only using two colors. Now there will be several on this assignment that will have right angles, and you are going to need to identify those right angles with your red pencil by drawing a little box around, or a little box in the corner. Okay, so that's going to take a little bit of your brain power, and if I had, oh, the index card is great, except you can't see through it. I would rather use a sticky note. If you have a sticky note, it works better because you can see through it, especially the yellow ones. That's what we'll be using in class. All right, question number 4 says you need to draw a parallelogram with no square corners. So when you draw a parallelogram, there has to be 2 sets of parallel lines. They're kind of hard to draw, but you can give it a little shot. Let's see. This is interesting. So I'm going to show you. I need you to draw a rhombus. Just going to say, you're going to practice drawing a parallelogram, which a rhombus is a parallelogram. It has 2 sets of parallel sides, but it has no square corners. By the way, if you draw a rectangle, not a good idea because it's got 4 square corners. So don't draw a rectangle and don't draw a square either. So a parallelogram has 2 sets of parallel lines with no square corners. These are 2 great examples. And I'm sorry, I can't help myself because I don't think they did a very good job of explaining that. So try to draw yourself a rhombus because it is a parallelogram, but it does not have any square corners, and that was a nice hint. I would practice that on another piece of paper because they're kind of hard to draw. Alrighty then, so there you go. And moving on to the next page. Now you're going to draw a quadrilateral that does have 4 square corners. I'm not going to give you a hint on that one because I just did a second ago. Alrighty, and down on number 6, you're going to measure and label the sides of this polygon to the right with your centimeter ruler. Okay, when you're using a centimeter ruler, you need to make sure that you're using a ruler that measures in cm, in centimeters. Now this particular ruler measures both in inches and in centimeters. Whatever ruler you're going to use, you need to use a ruler that measures in centimeters. Sometimes a ruler will only have standard measure with just inches. You're going to need to see if you can find one that has also metric measure, which is centimeters. Centimeters are smaller than inches, so if you're measuring with your inch ruler, you will not get an accurate measure. But if you do measure with a centimeter ruler, you will have great success on this. So you're going to measure and label the sides of this figure with your centimeter ruler. What do you notice? Be ready to talk about the attributes. That's what do you notice about its qualities, about this quadrilateral. Can you remember what this polygon is called? Now, I just told you that a few seconds ago, so I'd be like rewinding my tape here and go back and find out what this polygon is called. And I am going to say it would be a really good idea for you to take your little paper and see what kind of angles it has. Well, I can see right now that that one is not a right angle. Ooh, boy, can you see that right through the paper? I certainly can. A right angle would come down the side of this piece of paper, and I can see by looking right through the paper that this is definitely not a right angle. So I would be measuring or looking at all of those angles and deciding, is it a right angle? If it's not, then it's not a square angle. Okay, number 7, a square is a special rectangle. What makes it special? Well, I'm going to have you try that one. You're going to need to draw yourself a little square, and a square has to have all the sides exactly the same length. So make sure that you don't do a rectangle. Make sure that you are, well, a square is a rectangle. Yeah, there's a lot of interesting things that I felt like they should have been talking about. So a square is a rectangle, but I want you to think about what makes a square different than, actually it's the best polygon in the world. It's my favorite polygon because really it belongs in every group, and you got to figure out why it is so special. Okay, then moving on. Oop, that's the exit ticket. The exit ticket, remember, oh, I guess I don't have that one worked. So again, I would not use crayons. I would use your colored pencils to do this because crayons are too fat. So use pencils to trace the parallel lines on each quadrilateral, and again your index card to find if it has a square corner. Well, you know, I'm talking about a 90-degree angle or a right angle. But don't do this page until we've gone over everything on the other pages, because I think you might learn some interesting things as we correct these pages together. So with that, I am going to invite you to make sure that you watch the video. I would definitely watch that video first. Watch the Eureka video first, because she does do a pretty good job of explaining what you need to know for this lesson, but I would definitely watch that first before I attempted to do these pages. Alrighty then, so with that, I'm going to tell you to pause the video and then come back and see me in a minute, and when you're done, and we will go over what you did. Okay, pause the video. Okay, I hope you're back. Let's go ahead and take a look at what you did on this page. I hope that you did these on a bigger piece of paper, which I am going to do right now. Oh my gosh, I'm getting a little bit ahead of myself. So here we go. I am going to fold this just so I can demonstrate a little bit better what's going on here. I'm going to put this up, and for number one, here's the number one. I'm going to use this quadrant to help me. I had to use my ruler to draw two parallel lines that are not the same length. I just used my ruler to help me do this. So I took my ruler and I just used it to help me be able to draw parallel lines. It's a good way to be able to do it, like they demonstrated on the videotape. That two parallel lines, I know that they're parallel because they will never intersect each other. If I went on forever in both directions, these would never cross each other. And they don't necessarily have to be in that same position. They could be in this position. They could be in any position, really. They just can't be the same length. So that's another good example. Or I could maybe have one going this way. Just making sure that they are not the same length. Okay, so I have 1, 2, 3 sets of parallel lines that are not the same length. That was problem number 1. Let's move down to problem number 2. This time you were supposed to use your ruler to draw two parallel lines that are the same length. So this is problem number 2. This one's a little more tricky because you are going to try and get them to be exactly the same length. So I'm going to do this first one, 6 centimeters right to there. And I'm going to move, try really hard to keep them parallel, and draw this one 6 centimeters. Okay, oops, that one's a little bit longer. We want them to be the same length. There we go, so there's a set of parallel lines. Let's try another one, another direction. I'm going to draw this set to be 4 centimeters, and I'm very carefully going to move my ruler and try to make them exactly the same length. They don't even have to be that close together. They can be far apart like this one. They can be close together like this one. And let's do this one. We're going to make this set be 5 centimeters. Well, I went a little bit too far on that one. And let's move this over and try to keep those parallel lines the same length. A little more tricky when you're trying to make parallel lines that are the same length. Oops, I'm a little bit off. Too long. All right, so that's pretty much what you're looking for. You're looking for two parallel lines. 1, 2. This is a set of parallel lines. 1, 2, set of parallel lines. 1, 2, a set of parallel lines. And it wouldn't matter how far off I drew these. I'm just going to do a little demonstration here. These are not going to intersect each other. Uh-oh, I'm going to intersect that one up there. Oh, nope, I'm just going to barely miss it. Whoops. No matter how far I draw those, they are never going to cross each other. Sorry. Oh well, that one's not going to be quite the same length, so I'm going to shorten this one too. I'm going to shorten both of those because I want you to see that it wouldn't matter which direction I was going. These would not ever intersect each other or cross each other. I'm going to keep on going with that. try to keep them the same length, and no matter how long I draw them, they are not going to intersect each other. All right, so now let's take a look. This one was a little bit more tricky. This one was a little bit more tricky, but we can do it. We can make it work. So here we go. I'm going to show you the key for this one. I did blow this assignment up bigger for my face-to-face kids, and I wish that I could do that for you at home as well, because I think that's just too little for what they asked you to do. But you have to do the best you can with what you're working with. Alrighty, so on lines, oh, it's a polygon. On polygon C, you can see that it has two sets of parallel lines that I've highlighted in green, and you can see that it has another set of parallel lines that I've highlighted in blue. And I take my little piece of paper, my little sticky note, and I can see that, ooh, this one is ever so just barely not a right angle. If it was going to be a right angle, the line would come down like this, but I can see right through that paper that it is not a right angle. It's an acute angle. And if I look at this one, I can see that this one is an obtuse angle because it's just slightly bigger than a right angle, so I don't have any square corners or right angles. This one also is a little bit bigger than a right angle, and so is this one, although it is just a tiny bit smaller than a right angle, so it would be an acute angle. So now polygon D is different. It does have two sets of parallel lines. It also has four. There's one right there. One fits perfect. Two, oh, fits perfect. Makes a square of a piece of paper. Side of a piece of paper. There's number 3. And of course, there is the fourth square corner. All right, so you can see because each one of these angles makes the side of a square, it is called a right angle and has a square corner. And I really do prefer to use the word right angle or 90 degrees. So I have put a little square in each one of those corners. Whenever you see an angle that does make a right angle, they will always put a little square right in it, just like that. As you move farther down in geometry, you're going to see that that is how we indicate that it is a right angle. Okay, as we come down to polygon E does not have any square corners or right angles, and I can of course test that with my piece of sticky note. It's a little harder with an index card just because you can't see through it, but if you use a little sticky note, even with my overhead camera, you can see right straight through it. And of course, this side of the angle is larger than a right angle, which makes it obtuse. This one is also obtuse. And this one would be acute, smaller than a right angle. And this one is also acute. I can see right straight through there that it is not a square corner. If it was a square corner, it would come right down here. And it does not, so I can see that it is not a right angle. Now here we have a lovely little square. Look at that beautiful square. Isn't that fun? It has two sets of parallel lines, 2 green that are parallel and 2 blue that are parallel. And all the way around this thing has square corners or right angles. Now that's interesting because a square has to have all the sides be the same length. Let's see if they did that. Oh, that side is 2 inches. I'm just checking this out. Well, maybe that's not quite a square. That's more like a rectangle because this side is measuring, let's see, that's 2 centimeters. This one's a little bit shorter than 2 centimeters. Nope, this would not be a square. This would be a rectangle because all the sides are not the same length. We have 2. Nope, not a square. It's actually a rectangle because if it was a square, all the sides would have to be the same length, but it does have 4 right angles. Okay, here we have another rhombus, and it also has 2 sets of parallel lines. And if you take your little measuring paper, you're going to see that it does not have square corners or right angles. That one would be acute, too small, too acute, too fat, larger than a right angle. That would be obtuse. And this one is, let's get that right in the vertex. Oops, try that again. Alrighty, we can see that it does not make the side of a right, does not make a square corner. And so rhombus and a rhombus, they definitely, oh wait a minute, do they have the sides the same length? Well, anyway, and of course our last one is a trapezoid with only one set of parallel lines. Please be aware that I'm using proper language for naming what each of these polygons is, because eventually you're going to need to know that. So we have two rhombuses, two trapezoids, a rectangle. This would also be a rhombus. Nope, it's not a rhombus. This one is not a rhombus. This is just a parallelogram, a trapezoid, and we determined that this one was a rectangle and not a square. Alrighty, so there we go with that. And then you had to draw a parallelogram with no square corners. Well, okay, let's see if we can do that. Hang on just a second. I'm bringing in this one that I did earlier. So when I drew this parallelogram, I just used my ruler and I drew one set of parallel lines with my green, and I did another set of parallel lines with my blue, and I have no square corners. Those are obviously way bigger than a right angle. Does not have a square corner on that one. Whoop. This one is definitely acute. Oh, it's so acute. And if you measured all the way around, you would see that these angles are not square. They're definitely angles, but they do not make a right angle. Okay, and then I did a little smaller one too, just for me to practice. And if you would like to, practicing a parallelogram is kind of a lot of fun, and it is a fun shape to be able to look at. Okay, so now we're coming over to the next page, and you were supposed to draw a quadrilateral that has 4 square corners. Now you could have drawn a rectangle where it has 4 right angles that fit beautifully right into my little paper. In fact, here's a really great example. Even my little piece of paper would be a great example of a quadrilateral that has 4 square corners. My little piece of paper that I'm using to test for square corners. You could have also, I'm just going to bring over my template here for just a second, because I think drawing a perfect square is sometimes a little difficult. So I'm going to use my template to draw a beautiful square where all the sides are the same length, and it has 4 square corners or 4 right angles. It takes a little bit of practice to get used to all of the things that I'm talking about today, and I definitely like my little piece of paper for testing square corners because it's easy to use. Alrighty, so it could either be a rectangle or it could also be a square. And I'm going to put in my little symbol that says that each one of those corners is a square corner or a right angle. Now that's pretty beanie. All right, so now you were supposed to measure and label the sides of this figure or this polygon with your centimeter ruler. And what things did you notice? So I'm going to do this with you just because I want you to see that this side measures 3 centimeters. You see that? This side measures 3 centimeters. This side, 3 centimeters. And this side, 3 centimeters. So each of these sides is 3 cm for centimeters, 3 cm for centimeters, 3 cm for centimeters, and 3 cm for centimeters. All right, now, so each of the sides measures the same, so all the sides measure 3 centimeters, and there are no square corners or right angles. Do you remember what this polygon is called? I just noticed that I didn't have that written in there. So if it has all four sides the same length, which it does, 3 centimeters, 3 centimeters, 3 centimeters, and 3 centimeters, and it has no square corners or right angles, it is called a rhombus. It looks like a square that's been pushed over, but each of my angles are not square corners or right angles. It's a special kind of a square called a rhombus. Okay, now let's take a look at a square is a special rectangle. And what makes it so special? Well, I drew two squares. Each of the sides need to be the same length. I did a big one and a small one. So all the sides have to be the same length. It has 4 square corners and right angles. It also has 2 sets of parallel lines. I'm going to just show those little parallel lines just because. Now, if you are a square, you have all of the attributes that we have been talking about that make you a special polygon. You have all right angles. All of your sides are the same length. So you are called a square. You are also, believe it or not, you are also a rectangle because a rectangle has the same attributes except that all the sides are not the same length. So even if your sides are the same length, you still get to be called a rectangle. So we have a polygon because that's the general name for many-sided or many angles. It's also called a rectangle. And it's also called a square. So you get to be everything. You get to go to every party. You get to go to the square party. You get to go to the rhombus party. You get to go to the rectangle party. Now a rectangle can't come to the square party because their sides are not the same length. But anyway, that's what makes you so special, is because you belong to every party. Because you have all your sides the same length and you have 4 square corners or 4 right angles and 2 sets of parallel lines. Alrighty, so that was I really enjoyed doing that because I think geometry is a ton of fun. Alright, so with that, you are going to need to, now I would not trace this with crayons. I really would use pencils, your colored pencils, because it's pretty hard to trace those little beanie pieces with a crayon, especially if it doesn't have a brand new tip. And as I said, instead of using an index card, you can use an index card if you don't have any other option. But my first option would be to use a little piece of sticky note. It doesn't have to be this tiny one either. It could also be this bigger one, which is just a little more cumbersome to use the big one. But that would be my first choice. This is my last choice to use an index card. My first choice would be to use a small sticky note. And my second choice would be to use a larger sticky note. And if you can see through it, even better. And with that, while this turned out to be a really long lesson, I knew that it would be a long lesson, but a lot of fun things for you to learn. And if you have questions or concerns, or if you need colored pencils, if you need any of these tools, my friends, if it would be helpful to you, I would be so happy to get you colored pencils, to give you the sticky notes that you need. If I can be helpful, to help you with a ruler if you need, please come by. I would be so happy to give you things that you need to get through these lessons. And with that, I'm going to tell you to have a great day of learning.